I approached Harvard and MIT students with a question regarding physics and conservation laws. If you can correctly answer the question and clearly explain it using physics principles, then you possess a strong understanding of the branch of physics known as mechanics. Without prior knowledge of the question and no time for preparation, their unscripted answers are presented. The question is on the following slide. Do you know the answer? If you're interested in math or physics tutoring, please check out my website, acephysics.org, for math and physics tutoring with Dr. Hudis. And here's the question. An open wagon glides along a frictionless track during a vertical rainfall and fills with rain. How does this affect the cart's velocity, momentum, and kinetic energy? I have some larger pictures on the next slide to make it more clear. There's a cart and it's moving to the right with the velocity v1 in vertical rain. The rain has no horizontal component. This is time t1. Later in time, at time t2, there's more water in the car and the cart has moved to the right, and now it's moving with velocity v2, which may or may not be different than velocity v1. And finally, at time t3, there's more water in the cart. The cart is moving with velocity 3. The question I'm asking is, how does the kinetic energy, the velocity, and the momentum at time t1 compare to the kinetic energy, the velocity, and momentum at time t3 when there's more water in the cart? You might consider pausing the video to answer the question on your own and test your understanding. I will first show the students' answers. At the end, I'll provide the answer myself.
Yeah, so if it's going vertical, then the momentum of the water is completely vertical, which means the momentum of the car in the horizontal direction is not going to change as the water falls. But the mass of the car increases as water falls down. So then the velocity will decrease because momentum is conserved. Right?
Very good. Yes, of course. So now what happens to the kinetic energy?
Kinetic energy, so that's, what is it? That's p squared, so m times yeah, so kinetic energy is momentum times velocity. Velocity decreases, so kinetic energy decreases.
Do you know where the kinetic energy goes?
Where the kinetic energy goes. So let's see. What are the players in this game? You have the car, you have the water. The water started out with some energy. Oh, it must be heat, I guess.
Must be heat.
Yeah.
So the water
nowhere else it can go. Yeah.
The mass is increasing because of the rain falling in, so the velocity of the cart decreases.
And why does it decrease? You're correct. That is absolutely correct. Why does it decrease? You just said the mass increases.
Yeah, I guess if it's like frictionless and the only force is the forward force, so if the force itself isn't changing and the mass is going up, that means it's accelerating slower, so it's moving slower.
I think that's a great answer. That's a great answer. What do you think happens to the momentum of the car?
I feel like momentum stays the same. It's mass times velocity.
Perfect. Filling up with water.
Same.
Same velocity. What do you have a thought on that?
So when the car is getting heavier and heavier.
The car is getting heavier and heavier. That's true.
Yeah. So
it is frictionless also.
Frictionless also. I think the speed will become slower and slower.
You're correct. Why is that? Why do you think that?
Because the weight can increase the friction, right? The friction
Well, it's frictionless though. It's frictionless.
Yeah, it's frictionless. Oh, the frictionless?
Yeah, there's no friction.
Oh, there's no friction. I think if you draw the force map, one is from that side, and then the gravities go down, and then the common.
And here's the answer. How does the accumulation affect the cart's velocity? The velocity will decrease and the momentum will remain the same. As the rain falls vertically into the open wagon, it adds no horizontal momentum. The horizontal component of the momentum remains unchanged. Therefore, the momentum of the cart is conserved while the velocity decreases due to the increasing mass. Momentum is mass times velocity. If momentum stays the same and the mass increases, the velocity must decrease. How does the accumulation of the rain affect the cart's kinetic energy? Well, we know kinetic energy is 1/2 mv squared, and that can be written as p squared over 2m, where p is the momentum. The momentum remains the same while the mass increases, therefore kinetic energy of the system decreases. The kinetic energy decreases. The mass increases and the momentum remains the same. So why is this the case? Work is done against the gravitational force to raise the water's potential energy as it's lifted and moved with the wagon. The water at time t2 is higher than at time t1, and therefore the wagon has more potential energy at time t2 than it does at time t1. That's the main reason why the kinetic energy decreases, because the potential energy increases. But also, there's one other minor way that energy is removed from the system. And this happens because the water impacting the wagon causes molecular level inelastic collisions, converting kinetic energy into internal energy or heat. The process marginally elevates the water and wagon's temperature. AcePhysics.org. Math and Physics Tutoring with Dr. H. AcePhysics.org. Math and Physics Tutoring with Dr. Hudis.